Continuing on, pun partially intended there. We're talking about continuous functions. So a function f of x is said to be continuous at x equals a if the limit as x approaches a of f of x equals f of a. So kind of putting this a little bit into more context. This side here is talking about the behavior, what's happening to our function, and this is actually our function output. Now, a function is said to be continuous on an interval a to b if it is continuous at each point on the interval, every single one. Now, note that this definition is also implicitly assuming that both f of a and the limit of as x approaches a of that function exist. If either of these do not exist, then it's not continuous. So this definition can be turned around into the following fact. So f of x is continuous at the coordinate x equals a if the limit as x approaches a of f of x equals f of a. These next two look really similar. In fact, they all look pretty similar until you zoom in. Now it's kind of hard to see, especially if you're using a paper copy, and it got a little blurry on here. But the limit as x approaches a, and we got a little negative there, and then over here it'd be the limit as x approaches a, and it's got the positive there. That just means approaching from the left side. I missed a letter. Approaching from the left and coming from x equals a from the positive, that's approaching from the right. So all three things have to exist. So the point has to exist, and the other limits have to exist as well. So again, in general, there are three main points here that we need to address every time we're analyzing for continuity. So first and foremost, we need to say f of a exists. In other words, we can plug in some value for a, and it'll work for us. So that is to say, there's a real output at x equals a. The second is that the limit exists. So the limit as x approaches a of f of x exists. So not only can we plug something in, but the limit also has to exist. And we're going to say this is a predictable behavior. Based on what we see, it's got to be predictable. We can say, okay, it looks like it's going towards this point. Now, the final part is that f of a, the value that we plug in, has to be equal to that limit that we get as x approaches a of the function f of x. Now, some of this seems redundant, but we're going to look at some examples where it does kind of become important. So on the next page, we're going to look at a graph. Here it is. I'm going to erase all that work. Sorry, I didn't see that. We're given this graph, and we're to determine whether it's continuous at x equals -2, at x equals 0, and at x equals 3. So down below here, let's make 3 columns, try to evenly space them. That's not evenly spaced. Let me do a little bit better. There we go. That's okay. So starting off, we'll do x equals -2. Sorry, that's a shape. Let's try that again. X equals -2. So I'm going to kind of go through these step by step. We're asking, does f of -2 exist? Now, you do not need to write out these questions every time, but especially since we're doing this for the first time, we're going to try it out. So we're going to say yes, f of -2. We just got to look on our graph and figure out what the output is. Well, at -2, we're up here at that point at 2. So f of -2 equals 2. Step 2, does the limit exist? So the limit as x approaches -2 of f of x exists. Now, when we're looking at limits, again, we're using purely visuals here. So we're going to say coming to -2 from the from the left side. So following this along, coming at it from the left side, it's clearly approaching that +2. Now, coming at it from the right side, it's actually approaching -1. So we have to ask, we're going to say the limit as x approaches negative 2 from the left of that function equals 2, but the limit as x approaches 2 from the right of the function equals negative 1. Now I just realized I'm really far zoomed out. Let me zoom in a little bit. Now, as a result, the limit as x approaches 2 of our function, we don't really know what the function is, does not exist, dne. And as a result, it's not continuous. Oops, sorry. Not continuous at x equals negative 2. So it's got to meet all three criteria. It's got to have an output, it's got to have a limit at that point, and the output and the limit have to be the same. So for the second one, we're just going to check out x equals 0. And again, we're going to write less this time. So number one, what's f of 0? Does that part exist? Yes, it does. Looking at our graph, f of 0 is up here at 1. So f of 0 equals 1. Check. Move on. Step 2. The limit. Let's talk about the left and right side. The limit as x approaches 0 from the left side of whatever this function is equals, so coming at it visually, coming from the left, as we're getting closer and closer to x equals 0, it's getting closer and closer to y equals 1. So the limit from the left side is 1. The limit from the right side, as x approaches 0, of whatever that function is, same type of deal. Coming at it from the right side, we're getting really close to 1 again. So the limits exist, so therefore the limit as x approaches 0 of f of x equals 1. Good so far. Step 3, we're going to say, does f of 0 equal the limit as x approaches 0 of whatever the function is? Well, looking at this, it was a 1 when we plugged it in. We had the left and right limits, and therefore the overall limit's a 1. It's all the same number. Therefore, we say yes, and we can say it is, or the function is continuous at x equals 0. The final one we're asked to do it at x equals 3. So, at x equals 3, we got number 1, f of 3 equals, looking at our output here, the solid dot is down here at negative 1, so x equals 3, or say f of 3 equals negative 1. Cool, that exists. 2, looking at this visually, you can even just, you don't have to go through the left and right side. The left side approaches 0, the right side approaches 0. So we're going to say the limit as x approaches 3 of whatever function this is approaches 0. Step 3, however, f of 3 is not equal to the limit as x approaches 3 of whatever the function is. So again, since the output was negative 1, but the limit was 0, we're going to say the function's not continuous. At x equals 3. So it's continuous out at 0, but at negative 2 and 3, it is not.